9.2, we're going to learn about angles and radian measures. So drawing an angle in standard position. Here we just have a whole bunch of vocab and a coordinate plane, so that's this XY plane. An angle can be formed by fixing one ray, called the initial side, and rotating the other ray, called the terminal side, about the vertex. So we start at our initial side, which is always here. This is always going to be your initial side. And our terminal side is where we end. So if it tells us that our angle is 90 degrees, we would end at this 90 degrees here. So our terminal side is always where we end. And initial side is always where we start. So this is always, always, always your initial side here. This ray is your initial side. An angle is in standard position when its vertex is at the origin and its initial side lies on the positive x-axis. So again, when our initial side is here and our vertex is at the origin, so just meaning that that angle is at the center of our coordinate plane, that's standard position. The measure of an angle is positive when the rotation of the terminal side is counterclockwise. So if we go from our initial side up, this is positive. If we go from our initial side down, this would be a negative degree. Let's do some examples. So here we're just drawing an angle with the given measure in standard position. So for each one of these, we want to draw our coordinate plane. In our coordinate plane, one thing I forgot to mention on the last page, here, this is 90 degrees. We know that this is a 90 degree angle. So up top, this would be 90 degrees. Here would be 180 because this is a straight line, so this is 180 degrees. This would be 270. And our initial side where we start is always 0 or 360. Yeah, when you start there it's 0, but then when you go all the way around it's 360. So like when we start here, this would be 0 degrees. If we went all the way around the circle, that would be a full circle, so it would be 360. But now we're just going 240 degrees. So we want to go around to 180, but not quite to 270. So we're going to go to 180, and then how much more do we need to go after 180 degrees?
90.
We're going to 240.
Sorry. 60.
60, so we're going to go 60 degrees more after that, and then draw our terminal ray. So this is our initial at 0, and our terminal is at 240.
That's it?
That's it. Let's look at the next one. We have 500. So first we're going to draw our coordinate plane. If it helps to label your axes, go ahead. So we have 0, 90, 180, 270, 360. Here we're looking for 500. So if we go all the way around the circle to 360, we still have to go more than that. So how much more would we have to go? If we go all the way around once to 360, how much more do we have to go? 140. We would do 500 minus 360, and we have 140 left. So we're just going to go around 140 more. So we go past 90, not quite to 180. And we have here.
Do you have to draw a spiral so you can see that?
If it helps you draw it, but you don't have to.
So I could just do like a normal angle like that?
Yeah. So if it helps you draw the spiral, but if not, you could just have your angle there. All right, and let's look at C. So here we have negative 50 degrees. What's different when we have a negative degrees? It goes the other way. So instead of going up to start, we actually go down. So we're going down 50 degrees, which would be about here. All right, we have 4 more on the next page to practice. So first, we have 65 degrees. Where is that going to be? Perfect. It'll be here. So it's 65 degrees. Next, we have 300 degrees. So where would our 300 degree angle be? Bottom right. So we're going to go all the way around. All the way would be 360. So we're just stopping a little bit short of 360. And put our angle there. Number 3. We have negative 120. So where would this angle be? Bottom left. So we go down because it's negative. Down to our first, the bottom of the y-axis would be negative 90. So we have to keep going another 30 degrees here. So it'd be about there. And then next, for number 4, we have negative 450. So negative means that we're starting going down. Is 450 more than 360? Yeah, so we would have to go all the way around once. How much more do we have to go after we go all the way around once?
90.
Awesome. We would add 360 to this, and we have negative 90 left. So we go back down to 90. 90 is right at our y-axis here. So this would be like 90, 180, 270, and then 360. If we go the other way, so let's say we are looking at negatives, this would be negative 90, negative 180, negative 270, negative 360. All right, next, we're finding coterminal angles. So in example 1b, the angles 500 degrees and 140 are coterminal angles because their terminal sides coincide. So when we have an angle, let's say we had 30 degrees. If we go all the way around and back to another 30 degrees, and our terminal sides are on the same thing, our terminal sides are the same, these would be coterminal angles, when their terminal sides coincide. An angle coterminal with a given angle can be found by adding or subtracting multiples of 360. So most of the time, but not every single time, to find the positive angle, we would add 360. So this is to find our positive coterminal angle. To find our negative, we would subtract 360. And all of these questions about coterminal angles are going to ask you for a positive angle and one negative angle. And I'll get to an example where why it's not all the time that you do this. You'll see. So let's look at A. We have negative 45 degrees. So to find our positive coterminal angle, we add 360. To find our negative coterminal angle, we would take negative 45 degrees and subtract 360. So what's negative 45 plus 360 degrees? So it's like 360 minus 45. $315. So 315 is our positive coterminal angle. And then what's negative 45 minus 360? Negative 405. So that would be our negative coterminal angle.
You would have to graph.
All right, let's look at B. So here we have 395. So to find our positive angle, we add 360. To find our negative, we subtract. So what's 395 plus 360? $755. Yes. 755. What's 395 minus 360? 35. So this question asks for a positive angle and a negative angle. Do we have a negative angle here? Or one of these negative? No. So what we need to do here is subtract 360 again.
From both.
No, just from, like, we have a positive coterminal angle here. This is one of our answers. Now we have to find a negative one. So if when you subtract 360 and it's still not negative, you have to just do it again.
On the other one or the same one?
On
Like,
this.
I subtracted 360 from 755, it'd still be positive, right?
Right, it would still be positive. So then you would have to subtract again. Just keep subtracting until you get a negative.
Or would I just do it with the other one?
You just do it with the other one. Because if you get, let's say we took 755 subtracted 360. This would give us 395. And then if we subtract 360 again, this would give us 35. So we're still not in the negative.
Okay.
But we do end up with this, which we can just subtract 360 from that. So what's 35 minus 360? Negative 325. And this one's negative, so that would be our negative coterminal angle. So you just always have to be careful. If you start with an angle that's bigger than 360, you just may have to subtract twice. But also, for this one, since it asks us for a positive coterminal angle, 755 works, 35 also works. So either one would be the correct answer for the positive, but then you also just need a negative as well. All right, we have 4 more examples doing the same stuff. So how do we find our positive coterminal angle here? Add 360. What do we get when we add 360?
Oh,
440?
yeah.
So 440. How do we find our negative coterminal angle? Subtract 360. So it's 80 minus 360. Negative 280. Perfect. So we have a positive one and a negative one. We're good. Let's look at number 6. How do we find our positive coterminal angle? Add 360. So what's 230 plus 360? 590. And then how do we find our negative coterminal angle? Subtract 360. So 230 minus 360 would give us what? Negative 130. So we have a positive angle and a negative one. So we're good. Let's look at number 7. How can we find a positive coterminal angle? We can add 360. So it's 740 plus 360. 1,100. How can we find a negative coterminal angle? Subtract 360, so it's 740 minus 360. $380. Is this negative?
No.
So we have to subtract again. So 380 minus 360 is what?
20.
20. Is this negative? Nope. So we have to subtract 360 again. What's 20 minus 360?
340.
Negative 340. Finally, we have a negative. So this would be a negative coterminal angle. For a positive coterminal angle, you could either say 20 degrees, you could say 380 degrees, or 1100 degrees. All of these would be correct positive coterminal angles. All right, let's look at number 8. How do we find a positive coterminal angle?
You
Add 360. So it's negative 135 plus 360.
add
225. And then how do we find a negative coterminal angle? Subtract 360. So negative 135 minus 360. What does that give us?
Negative 495.
Negative 495. Are one of these positive and one's negative? Yep, so we're good. Alright, next. So, when dealing with circles and coordinate planes, in the last couple examples and in the past, we deal with degrees, but we can also work with radians as well. So, we have 360 degrees is the same thing as saying 2 pi radians. So it's just a different way of measuring degrees. Instead of degrees, they just call it radians. Similarly, 180 degrees is just pi radians. So when working with it, these types of examples where it gives you either radians or degrees, just be careful because degrees will always have that little degree symbol. Radians will sometimes say radians after, but not always. But radians just won't have that degree symbol. So if the degree, that little circle up top is there, you're talking about degrees. If it's not there, then you're talking about radians. So here we're going to be converting from degrees to radians and from radians to degrees. So to convert from degrees to radians, we multiply whatever degree was given to us by pi over 180. And then to go from radians to degrees, we multiply it by 180 over pi. So these are the two little formulas you need to know when to convert. And just be careful when you're going from degrees to radians, know the difference between going from radians to degrees. So let's look at some examples. So convert the degree measure to radians or the radian measure to degrees. What do we have here? A degree. So what do we have to do to change this to radians? Multiply by what? Pi over 180. So we can simplify. We can take out a 10 here. So we have 12 pi over 18. We can take a 6 out as well, so divide the top and bottom by 6. So we would have 2 pi over 3. Any questions there? All right, let's look at B. Is this in degrees or radians? This is in radians. So how do we convert it to degrees?
180 over radian.
Multiply it by 180 over pi. So the pi on top cancels out with the pi on the bottom. So we just have negative 180 over 12. How can we simplify negative 180 over 12?
6.
A 6 goes into both of them. So what's 180 divided by 6?
30. Or
Negative 30. And 12 divided by 6 is 2. Can we simplify more?
Yeah. 15.
Negative 15. And are we talking about degrees or radians here?
Degrees.
Degrees. So we have to put that little degree symbol there. Oops. So next we're going to look at degree and radian measures of special angles. So if we're looking at our circle here, we know our special angles are 30, 45, 60, 90, and then it applies for everything around the unit circle. So every 30 degrees, every 45 degrees, these are special angles. So we know that 30 degrees is the same thing as pi over 6 radians. Sandy, this is in the notes.
Oh, right.
So this will come in handy when, like in pre-calc, but we can always just convert 30 degrees by multiplying it by pi over 180 and simplifying. So that's another way we can get all of this, but this is called the unit circle, which you'll do more of this in pre-calc. But these are just showing you your special angles. So let's convert some more. For number 9, we have 135. Is this in degrees or radians?
Degrees.
Degrees. So how do we change it to radians?
Pi over 180.
Pi over 180. So we have 135 pi over 180. How can we simplify? What goes into 135 and 180?
What was one of the special ones?
So
Could be 3 pi over 4.
perfect. Sandeep said it's one of the special ones, which is 3 pi over 4. I think 45 goes into both of them.
I wouldn't even.
Yeah, it does. 45 goes into both. So if you divide the top and bottom by 45, you would get 3 pi over 4. So again, you can use your circle on the last page to help you out, or you can just simplify. All right, let's look at number 10. 10 is not one of our special ones. How do we convert this to radians? Multiply by pi over 180. So we get negative 40 pi over 180. We can cross out the zeros. So negative 4 pi over 18. We can divide both by 2.
Negative 2 pi over 9.
So we get negative 2 pi over 9. Now with the radians, you don't have to write radians every time. It's kind of just understood that if nothing's there, it's in radians. But with degrees, you have to put the little degree dot to show that it's degrees. All right, number 11. Is this in radians or degrees?
Radian.
It's in radians. So how do we convert it to degrees?
Multiply 180 over pi.
Multiply 180 over pi. So pi's cancel out. What's 180 divided by 4? Anybody know? Oh, it doesn't go in, does it?
No.
It's 45. So then we're just left with 5 times 45. What's 5 times 45? 225. And then we have to put that little degrees symbol there. I think this was a special one also. Yeah, so it's on our circle. If we just look and see where 5 pi over 4 is, we know that that is 225 degrees. All right, number 12. Is this in radians or degrees? Radians. So how do we convert it to degrees? 180 over pi. So whenever it gives it to you in a decimal, you can give your answer in a decimal. But whenever it's not, you have to give me like a exact number. Like here, where we had to simplify, we just couldn't put this into the calculator. For this one, we can just put it in the calculator. So we would want to do negative 6.28 times 180, which gives us negative 1130.4. And then we want to divide that by pi. So that would give us negative 359.8. Is this in degrees or radians? Is our answer? Degrees. So we have to put that little degree symbol. Since we have time, I'm going to do the last two examples. So I multiplied these two together and then divided by pi. Yeah. Okay, I'm going to talk about the last example since we have time. That way you can do everything from the homework. So a sector is a region of the circle that is bounded by 2 radii and the arc of the circle. So a sector is everything in here. This is our sector. The central angle theta of a sector is the angle formed with 2 radii. So this is our central angle, the angle that's at the center of the circle. And then we have our formulas here to find what the area of the sector is and our arc length. So our arc length is just what it is, the length of the arc, but the sector is like the whole area of that piece of pi, like the piece of the circle. So our formula for arc length, S is arc length. So it's S, arc length is equal to R, which is whatever our radius is, times theta, which is our angle. But here we have to be careful because theta is always measured in radians. So if it gives us our angle here in degrees, we have to convert it before we plug it into our arc length formula. So super, super important that your theta is always in radians. And then our area is just 1/2 our radius. Times theta, which again is in radians. We want an exact answer here, so we wouldn't just want to plug it into our calculator. But how can we simplify? Pi over 2. So we're multiplying this by pi over 2. What is 200 times pi over 2? Awesome, 100 pi. So our arc length is 100 pi. That's our answer for arc length. 100 pi what? What measure do you think this outfield fence is? Is it like yards, miles? Feet. Since this was feet, our answer is in feet.
Because I didn't write
Maybe. Should always just put the unit. Alright, next let's find our area. So what's our area formula? 1/2.
Base times height.
No, the area formula on the last page, area of a sector.
R squared theta.
R squared theta. What is our radius? 200. So 200 squared. And what is our theta? Pi over 2. Same thing that it was before. Pi over 2. What is 200 squared? 40,000, perfect. So 40,000 times 1/2 times pi over 2. So let's just do 40,000 times 1/2 first, which you can do this in your calculator, or you can do it in your head. What do we get? 20,000. And then we have 20,000 times pi over 2. So 20,000 times pi would just be 20,000 pi over 2. So we can divide 20,000 by 2, which would be 10,000. Perfect. 10,000 pi. What do you think our area is measured in? What unit do we have to put here? But area is always our unit plus what? Unit
Squared.
squared. Perfect. So feet squared. That's our answer.